Now we can make this be two different hypothesis tests. If you guys want to turn one of these in as an in-class quiz, that's fantastic. So if you want, grab two sheets. We'll do one for each. We'll do one for the neighbor's data and one for the cop's data. That makes sense? Yeah. That way you don't have to lump them all into one. Well, you can if you want to.
I have it all in L1, L2.
L3, L1. Well, that's totally fine. That's totally fine. But let's write up each test individually. I see what you're saying, but I think that's very wise to do. But as far as when we submit it, let's pick whatever we want to submit. We'll get back to that in a second. So, the question I have first. Either one show that cars are speeding, in your opinion. Upon first glance, we got cars speeding anywhere. They both do. Looks like they might both show cars. Now, Michael, why do you say that?
Because there seems to be a concentration around.
Oh, Harrison. Sorry. Go ahead, Harrison. I'm sorry. Go ahead.
From 30 to 35 to 35 to 40 on both police data and vehicle data.
Good. It's a relatively sized concentration, but the police only have about, what, 10, 15 data points.
Yeah.
But of those, half of them are concentrated between 30 and 40, implying over 30 miles an hour. Good. Now, again, when I say speeding, I'm not trying to give a number of how far above 30 you have to go to be speeding. I'm not trying to say that. We can make a confidence interval, do that if you want to. But just, are they above 30 significantly? Or are they arguably within 30? Good. Now, and the neighbor's data looks like has roughly the same thing. They got about 100 data points maybe, ish, and roughly half of them. So if you think about it, both data points show the same-ish average, don't they? Both look like they show the same, roughly the same average, same shape of the data even. But there's just more in the individuals. So which data set is going to have the smaller standard error? The individuals has to, doesn't it? Remember your central limit theorem? I erased it now. I said I wasn't going to because I might want to point back to it. I just pointed back to a blank screen. Your standard error is governed by the sample size. The neighbor has about 10 times more. That means his standard error is going to be about 2.5 times less. Root of 10 is about 2.5-ish. No, 3. About 3 times less-ish. Cool?
So if we did this with L1,
We are going to.
we can do L1, L2, and L3.
We can, because the exact same data is 15 to 20, 20 to 25, and so forth and so on. So I say we do L1, L2, L3. Let's do it right now. Yes?